Check, check, check. 1, 2. All right. Hey everyone, Lazy Ben. Welcome to a new week. All right, so let's just quickly make some new notes for the week. See what we did last week. Okay. So what I'm going to do is actually make a new list called current week. And I'm going to put this here because this list is just going to get so long. Be nice to, whoops. It would be nice to have not scroll down this list all the time to find what I'm currently working on. So we're just going to rearrange this list here before it gets too big. I wonder if you can actually sort it. Sort by date created, newest first. There we go. And I don't actually need this. Archive. That's better. So week 18, which is the 30th of June to the 4th of July to Independence Day. Okay. So I'll just put in a checklist. Well, let's just go back to last week and see. So work on eliminating dynamic allocations in game events, hybrid storage, hybrid lander. That's like half done. Speed up the pathfinding, nope. MP instance system, nope. And we're actually working on a different thing at the moment. Well, this is working on. At the moment, we are working on limiting dynamic allocations. That's the thing we're currently working on. So let's just make a new checklist. So let's copy these over. Got those 3 things to do this week. So nothing really new. Well, the NPC instance system will be new. These 2 are kind of like maintenance tasks, really. Okay. So currently right in the middle. So I did a bit of work over the weekend on this reducing dynamic memory allocation stuff. And we're right in the middle of it. Part of this, what it's turned out to be, is we're just tidying up the use of dynamic allocators in general as well. Which are halfway through, so the game's not compiling, but we're just working through errors. Compile errors now, and that's what I'm going to spend the first bit of today doing. I'm not sure how long it's going to take. There might be quite a lot to change. Okay. So we've changed from these global heap allocators to using the global heap directly. get rid of that because that's been if zeroed out for a long time now. So let's just look at everywhere he's globally allocated. Here's only that one instance in this file. So we're just going to keep building, correcting compile errors, building, correcting compile errors until we are done. So I might actually go over to the debug build for this to work on one file at a time rather than the mono build, which compiles several files at once. Okay. Then I can just stop, like, go into helpers. Now let's put problem details here. Error list first. So now we can go into helpers and just correct things as we go, files as we go, rather than having to deal with multiple files or compile errors in multiple files at the same time. So this move to string isn't a thing anymore. It's just toString. Okay. Trying to create a string of the wrong char type. Ah, right. We want to empty a string. Right. So what was empty? What are we even doing here? Let's just copy that out. Comment that out even. Okay, so how would we do this then? We need to get the empty string depending on the car type. So I think all we're going to do is we're going to go if can we do chart encoding v? Well, we can actually ask it what the character encoding is. So we've got this thing, so it is ASCII. So we can say if context ber is ASCII, else if context ber is Unicode, non-string char type. Can't just say is ASCII. Yeah, we can. Surely we can. Why can't we say that? Identifier not found. Say this. Okay. Next one. No except cannot convert from T. Okay. T from DX12 read block to DX12 read block. It cannot bind to an R value reference. dx12 read back even. So this is where it's trying to move a read back. Let's work out how we move this. Thinks it's an R value reference. That's very strange, that. Let's just if zero this out, because that's where we're adding things. So it's not even there. It's literally creating the array itself that it has a problem with. But if that's just a normal array. So what does a readback have in it? Just pointers, a draw context, which has got some stacks and stuff in it. Right, so it's because these need to get sorted out first, I think. So let's just hang on. Let's just go back, put that back to how it was, which is yeah, it's currently the same. So the stacks. So we're changing this to a static allocator now. We're removing these. So using allocator type. So we're changing things to static allocators, which is nice. Let's just remove these. So this is just stack base equals default. And then both of these get to disappear. Okay, and the allocator dots are just now allocator colon. Wait for Visual Studio to catch up. All right, so let's just go back here again, wherever we were. See if this builds now. Still has this problem. 12 read back. So it has these contexts. Stack, array, stack. And they're all just pointers. Push buffer base. Cannot move. What a weird error this is. No, except cannot move from T to, so it thinks that the actual element is a right hand side, the actual value of T. TYBM read back. I wonder if it's just because it doesn't have a move constructor in it. Let's do this. Put a breakpoint there. We'll see what happens. It seems to be all of them with the read back function. DX12 read back. Canvas draw range of reference type. So what is a canvas draw range? I wonder why it's a reference type. Readback token. Let's figure out how this works then. The value is canvas draw range, readback token, canvas draw range. So rather than hold references, we could hold pointers. And what is completed readbacks? Readback token. I just want to know why it's holding references to them. I wonder if... And how much problem this will cause. That seems to work. Root signature, no overloaded function could convert all the argument type. We're trying to match TW string. So what is output? Root signature. So this is just const. This is an operator. This is old code, man. Compile error. Errors. So this is just const. Shader. In place standard move shader. Shaders. Problem here with just setting a reference. Now we're going to be const. Can't go from const to do we have one or the other? In place with no arguments. Okay, so what happens if there's no arguments? Now we're into this same problem here. Else if const expr standard is move assignable. So it really doesn't like the readback. It really doesn't like having references in there. Okay. Of reference type. Never had this problem. Never used to have this problem. Don't really want to copy the token, right? So we're just going to hold references, hold pointers instead. And then the actual state here, we'll just pass the addresses of here. Okay. Get readback compiler. Now I've changed them to pointers. So if the pointers aren't there, if not draw range or not token, return e fail. There and there as well. Okay. Okay. Associated constraints are not satisfied. So what is the allocator? This needs to be a static allocator. So all of these really need to be static allocators in this file. Okay, push buffer base. So the allocators in this file as well. This needs to be a static allocator. Okay, all these need to be set. This is just the default constructor now. There's no default allocator anymore. This is sound base. It's default. Sound base has in it a buffer allocator. So both of these can go. Right. Sound base. So they're not allocators anymore. They're straight on the global heap or the global temp arena. Still have this problem here now. Doesn't like this read back. Global temp arena get space. So it's calling move range. It's basically saying it cannot call standard move as an operator on the read back. Oops. Either cannot move this, it's just a pointer, so it can definitely move that. The D3D12 draw context. So it cannot move a stack. Ooh, I don't think it can move a stack. Did I accidentally delete the move constructor out of this stack? Oh, there it is. There it is. And there's the assignment. So it can move a stack. There we go. That compiled it. Detached buffer constraints are not satisfied. So what is this allocator? Where are we? We're in image here. Okay, so image does need some work. What does 0 do? Mem sets everything. So do this, and then the image view just needs the default, able to recall the default constructor. And then the image now, let's just check there's nothing in the image which needs setting. It's only got the buffer allocator on it. So that means this can be default. And both of these can go. These can go. That can go. That can go. That can go. I think. Width, height, channel count, yeah. Width, height, channel count, bit depth. Straight up an image view. Okay, let's see if this. Let's see if that can build now. Member function already defined. Right, okay. So what's this? Image-based template parameter allocator is incompatible with declaration allocator. Okay, that's probably because, yeah, I didn't fail the constraint there. It's probably because the allocator is passed to the buffer allocator instead, whatever it is here, and that constraint didn't fail. All right. Okay, what's this? So it's not that. That was not the problem. Declaration of allocator. Don't exactly know what that means. Oh, image viewer is a static allocator. That's why. Who's the friend declaration? LibBM and LibBM graphics are both compiling. Fine. Now. So let's swap over now to the mono build and stop compiling the individual files, because I think the rest of it's hopefully getting rid of these unallocators and just making them stack allocators. Mind you, here we're still in the LibBM stuff. Alright, we'll just keep going. Oops. That's the same. Okay, so all these allocators need to go. That allocator needs to go. That allocator needs to go. Alright, let's see what happens here. So this is the same thing, where we must have forward declared it somewhere else. Yes. We may as well do static. May as well do path view here as well. a lot of utility code. That's a static allocator. And then these are gone. We may as well put using allocator type allocator there as well. This is all private. Interestingly. Okay, that allocator can go away now. All right. So let's just see what we get. Path view. So all these allocators can go away now. Right. Cannot convert from item list bounds to item list bounds. So what is item list bounds? It's an array of rect. Cannot convert from const item list bounds. Right, well, that should be able to copy. So why can't we do a copy assign on an array? Whatever that is. Operator takes the right hand side of const t. Um, right to do that. Doesn't appear to be. Let's just put the const one in as well. Cannot copy construct item list bounds to ambiguous copy constructors on no available copy constructor, it says. So that is to do with this array. So we don't have a copy constructor, it says. For const. We don't for const. Okay. Maybe, you know, where would it be? Well, let's just find the operator again. Maybe we need both of those. That's const now. Yeah, I think that worked. I think that worked. So the operator as well. Maybe we just need this. Not that one. Here we have const on the operator. And const on the constructor. This as well as maybe const ref as well. right. Cool. So, to asset path. So we have no matching overload. To asset path for a string view. Could be want to a string. So string or string type it is. I wonder why not a string view. So that copies it into a string and then returns the string. So they're basically the same. That doesn't like the fact that it's a string view there. Fail to specialize function template. So it's this. So the underlining char type. Static allocator evaluated to false. Okay. That there. allocator, see if that works. Looks good. Okay. So it's because this is a W string and it wants a TW string. Right. This is apparently a W string. Because to asset path, it returns from the global heap here. So if you pass in a TW string, I reckon it wants to return a TW string. So we need to get the allocator out of there. Somehow. So who's calling to asset path? Quite a lot of places. That's a W string. That's a W string. So we could specialize on okay, so you could do concept static allocator. I don't think it's going to be able to work out the allocator from there. No. So it can be default onto the global heap. If we pass an actual string, so there'd be something like car type concept static allocator. This is just string base. and it kind of needs to return the same thing. So we have the car type now. So the only thing is it might get mixed up between these two now. I think that worked. Okay. Static allocator. All right. So cannot convert from const w char pointer. Okay, so the string so it does have a does it have a constructor that takes a pointer? There's an operator that does. Doesn't have a constructor that does though. But now we've got ambiguous calls to overloaded functions here. Okay, we've got a different error now than what we had before. Cannot convert from initializer list to BM room enter. Room name. So here we go. It cannot put it in there. So it really does need a constructor. But it's to tell the difference between these two. Because now it's ambiguous with this. Can we just say if it's a pointer? Decal type of... Oh, we don't know what strut is. Requires standard is pointer. Okay, I think that actually worked. All right, cool. Let's move on then. We'll see if that did actually work. So where are we now? We're in helpers. So this is a static allocator. Right. That's good. Oh, we are nearly compiling it all now. Okay, so what's this? Must return a value. So we possibly do want to check that as well. I think it's fine. Okay. Where are we now? So, undefined of use of type, default allocator. So this is the blob allocator. We've got type name allocator. So this is concept static allocator. And the 0. This is null pointer. And This can go to the default constructor now. These two can disappear. This can disappear. This can disappear. Malloc is allocator. Malloc. Free is allocator free. Get allocator is not a thing. What we need to do is we need to say using allocator type to allocator instead. Okay. This is allocator free. Alloctor. We've spelled allocator wrong. Okay, and then these two now. Whoops. Are directly on the heap in the global temp arena. Nearly building. This library's nearly building now. Almost. Okay. Array base. So this is a like allocator. Oh, interesting. So when we call pack, passing in an allocator, which is the blob allocator, different type of allocator. So we need to actually, this needs to work a bit different now. Because we can't pass it into the array for the for it to be the allocator to use anymore. So that's what we're taking out. So we could just use the temp arena, couldn't we? This is for it to not really use too much memory. Because we can just we're saying the blob allocator there is using the global heap though. So the packer so we call try pack into bucket with a rect packer. This packer is a rect packer. Pack into buckets. This packer is a rect packer. This is STB rect packer. That gets the allocator. Which isn't really a static allocator. Alright, I'm going to check this in. Have a 2-minute break, make a cup of coffee because I haven't had one yet this morning. This needs to be slightly rewritten, I think. Because this was, what we've done is, instead of array base, you can pass in an allocator to it. We're making the array bases use static allocators now. Which means that this needs to use a static allocator as well. So I'll have to rewrite it. I'll be back in 2 minutes. Right, so how do we want to do this? This definitely cannot take in an allocator. Go back to concept. Oh. We do have a rect packer, I think. No, I don't know. A rect packer. Where we pass in an allocator. So I think this is going to change, right? So it's going to be like this. And then the STB rect packer doesn't do this anymore. These go away. And is there any other packer that we use? No, only this one. Okay. And calls pack into buckets. Okay, so this is where we're packing in the allocator. So the packer itself. So pack. We need to send in the allocator. So we could make the blob allocator a static one. Because this just uses the heap. Anywhere else that uses the blob allocator? Looks like just in packing. You see, we could just do it on the global heap, couldn't we? And just remove blob allocator from the game. Okay, let's do that. The blob allocator is gone. We don't need to do this. This pack is literally just going to use an array. And the blob allocator can go. So where is the blob allocator? Blob allocator. Delete. And the nat.viz blob allocator can go. And wherever we include the blob allocator. There. Okay. It just uses a straight up array now, which is simpler, which is lovely. And that's no longer a thing anymore, so that just goes away. That just goes away. Let's just see if this can build now. So we are setting some kind of allocator here. And that's probably why we wanted to pass through the allocator into the actual packer itself. We could do this. That can be array base. That allocator. Try it that way around. Because we probably have definitions here. It's only the global heap. We're only packing on the global heap anyway. So it does have a static allocator associated with this. What's the problem? It doesn't like that. Why doesn't it like that? Unexpected tokens. It just doesn't like me putting that there. Like we're calling pack. It's because we're not passing it as a. So you cannot do that. STB rect pack. So the tile book itself, don't think has whatever allocator it needs to use. So it's the rect packing allocator type, really. Because we could pass an instance of rect packing in, and then we get the allocator off that. Which doesn't force it to you. Mind you, like this doesn't force it to use the allocator. Or, you know, we just do this. And we don't pass any allocator at all. And it just uses the heap. Where are we? So we've got blob allocator there as well. In the shader reflection. Don't use it though. Why does this thing called bind to allocator? So complicated. And it calls get bound allocator, raw string reader for a particular allocator. We could just have all this happen on the heap. So it just basically reads this in with that allocator because it just needs to allocate some memory. How does this work though? We are using it quite a lot. It puts it on the heap anyway. It puts the string on the heap. Okay, so let's just do a static allocator for this. Just pass in the strut. Do need to save. And this is the global heap. Like this, and then we just want using allocator type is allocator, and then so this always puts the returning string. It's a t-str, and it copies it into some pointer, which is actually just allocator. Oops. So allocates it. So it allocates a pointer, it copies into it, and then sets it. But this t-str here, it's read out on the heap and then copied over back into the heap. Which is a bit weird. So we may as well read it out into the global temp arena. Temporary string, allocate it, copy it back out over into the heap, or whatever allocator is specified in the raw string reader. All right. Let's put actually a breakpoint there as well. Okay, so I don't need to do that anymore. Blob allocator, reader, get bound allocator. Okay. We call bind allocator. What are we actually sending into that? It's the bind to allocator. Do we want to bind? So it's the bind to allocator. I think we actually want to send in. This is very confusing. Equals allocator. And then the get bound allocator is so you call bind allocator bind to allocator T, bind to allocator. Why is this so complicated? So I think we're going to say this is just class bind allocator. And then this is just the address of the bind allocator type. I think. So the bind to allocator means we just bind to the global heap allocator. The global heap even. And then we're calling read and with this allocator. It's confusing as man. We call read with allocator T. We're reading bound to this, binding this allocator, then we're reading. So I assume what that means is we want to use whatever this allocator was. Oops. So get bound allocator kind of doesn't work now. There'd be something like a static allocator. It returns the allocator unwrapped. I don't think this makes sense, really. No. Doesn't make sense now we're not storing the allocators. Like, we would have to store Malachan free, really. So raw string reader. I think we just do raw string reader, global heap, desk semantic name like that. As the new, I'll just default raw string reader. Basically, just does that. And we totally get rid of all of this bind allocator nonsense. That means that goes away. Those three go away. Okay, let's see what problems that's caused. This bind to allocator is gone as well. Let me do a binary serializer of bind to allocator. So that's gone. Expected an expression instead of a type. So this is read. This is just default string reader, default raw string reader. And hopefully a raw string reader can get read. Yeah, so this is where we put it into the temp arena. And then we read it out. And then we copy it into the string reader. As a raw string. Do we need to do that though? Can't we just... do this? Static allocator. Make a str. Because it's going to get... read it out. Because the string's going to get released. Okay. This string would get released, so we need to actually copy it back into something that's not going to get released. That's why we do it. It's pretty slow. I think it's okay. Okay. So that looks like why that, because it's not a raw string. So it's kind of like this we want. We kind of like want a raw array reader, really. Which is kind of the same. So we'll do something like template class array type. Concept static allocator struct raw array reader using allocator type is allocator raw array reader. It's a raw array reader. And then wherever we were, semantic name, so that's a string. This is a raw, well, hang on. We'll make a default one, template class array type using default raw array reader, like that. It's the raw array reader array type. Global heap. And that's just a default raw array reader like that. Because this is an array of D3, D12 input element descriptions. Well, it's actually just an array of them. It's not a raw array of them. Actually, this could maybe just be that. We take out the raw array reader. Didn't actually need to do that. It's not a raw array. All right. So let's actually put a breakpoint on there as well. Go back to the errors. Where are we? Raw string reader, static allocator. So this is just allocate a malloc. Like that, I think. Let's get rid of the music for a bit, that's a bit annoying. Okay, let's move on then. Blob allocator. Compression allocator. So this is a similar thing. To the rect packer, I believe. LZ4 compression. So we're just going to compression encoder. No such thing as an allocator anymore. Compressor. So it's a static allocator. Okay, so this is really doesn't have anything to do with allocators. Because we can't call compress allocator like that. Didn't like that before. That's what I would like to do. And then the LZ4 compression as the static allocator. I don't think you're allowed to do that. That's the problem. Maybe you can do it a different way. Like, it's definitely not going to like this. So the decompressor that's global heap. Let's use template argument for decompressor buffer allocator. So that's just a buffer. Did I delete something here? So that's where we want to decompress it into. I believe. So this is actually an allocator, because when we decompress it into a buffer allocator, so LZ4 is like that. That's kind of a bit more confusing. No matching overload found. Decompression void pointer size T. Or decompression void pointer size T. Okay, so it's failing the concept. We just compress it on the global heap, but we're going to decompress it into a buffer. This should be a buffer, really. A compression decoder concept shall not have associated constraints. Yeah. Hang on. just class allocator it wants. So I wonder if I should name these to buffers, really. It's a bit confusing. So we don't really need the blob allocator there now. It needs to compress on the global heap. So I want to change this to buffer. Or result buffer. Like this. And this is actually a result buffer. It just returns the view of it, but the result buffer, because like the result buffer could already have stuff in it. So this just returns the view of the decompressed data into that buffer. So there's no allocator. It's just a compressor, and then we're going to compress on the global heap with LZ4 compression. So it doesn't like this. It doesn't like doing this. So I think actually, so if you do compress, we could do this. LZ4 compression, global heap. Like that. And then the compressor doesn't really need to care about the allocator. So that can go away. This is just template class compression. And this is No, it's a compression encoder, but it doesn't need to know about the allocator. Like that. And then we don't need to do this. That's a little bit cleaner, that. A little bit of a cleaner API. You know, we could do the same with rect packer as well. So we could do class template concept, the static allocator like this. And we don't necessarily need. So it's saying that this doesn't work. Pack into bounds. No matching overload found. With rect type is rect u. With scalar type, the associated constraint, so it's the rect packer constraint, is not working. Oops, not there. So that's the constraint. Why isn't the STB rect packer? Width height rect count returns a bool. Cannot convert from tile set rect u to rect type. Pointer. Because it wants to pick this one. Begin and end. Back into bucket and calculate bounds. Where's the one with the range? Here. There we go. All right. So why doesn't it like that? Do we need to actually include global heap? Now is Charlie included? Oh, it may not have. So actually, that goes there. So this is just like compressed with LZ4 compression into the global heap. Yeah, that sounds good. Then it returns a view back. Problem with doing that is it won't free. So really it needs to free when the compressor goes out of scope. So that's not ideal either. It looks like it's building though. Apart from a bunch of linker errors. Oh, there's a few compile errors. Quite a lot. So I think the compressor does need like actually an allocator, because it needs to free once it's done. So it needs a result buffer as well. Like that. It's literally the same, really. Whoops, that's there. This is a result buffer. And then we actually do need to pass in the result buffer. There and there. And then the LZ4 needs to take a result buffer. So this is really just a result buffer. Like that. And that's the result buffer. Hey, alright. It is hot in it. Doesn't actually need the allocator anymore. All right. So this needs a result buffer there. And this compressor, we need a buffer allocator. Like that. And then when that falls out of scope, the compression falls out of scope. So compressor, no matching overload found, it says. So these are kind of the same now. The decoder and the encoder. Did it pass the result buffer in? Okay, so that's result buffer. Right, cool. So, what's the problem here then? No matching overload. Range begin. So the packer. So the STB rect packer. Again, we have the same thing where we could do a bunch of stuff. Yeah, this doesn't need to really care about what allocator it gets. So it's the range one. So a rec packer now doesn't actually need any allocator. Yeah, I'll come and tea. That'd be lovely. Thanks. So we could take that away. Well, it has rec pack in generic. Yeah, that'd be great. Thank you. Yeah, I think it does need an allocator actually. That one doesn't need the allocator. So the packer itself's allocator could be different from the requested allocator. Which is not great. I mean, they are just all heap, global heap anyway, so it's fine. It just means you could request rec packing on the global heap, and the packer itself could use a different allocator if it wanted to. Pack into buckets. So look at all these. There's only that one. So I've changed so much now of the foundation engine code. Hopefully not introduce any crazy bugs. I'm only changing the allocator over though. Or the way we allocate over. So it should be okay. Allocator must be initialized. Okay, so this is detached buffer. We don't need allocator there. And also these should be set. Nearly there. Might build this time. Looks good. Just thinking about it. Yes, it built it. So the BM engine now builds. Just needs to build the game. The game probably doesn't use any crazy allocation strategies. It looks alright. It looks like it's going to build. Alright, awesome. Built. Oh, not quite. One of them didn't build. So we're building all the libraries. Look, resolve string type. Saying use global temp arena. So this, where was it? Is actually resolve global temp arena. Like that. Return null pointer into a string. Interesting. I think it should just be W string. And here as well. Global temp arenas is the same as the other one. There we go, we're built. All right. Oh, thank you very much. Doing all right? Nice one. Yeah, yeah. Go for a curry this week sometime. Sounds good. Yeah. Yeah, that's fine. No, that's fine. Oh yeah, can never have too many though. Yeah, yeah, yeah. Yeah, exactly. So it looks like we're not even using memory arenas in the game. I'm just talking. I'm talking into the code. Yeah, yeah. So we won't remove them, but we will have them work with the new system. Okay. So we'll remove the allocator out of it now. So this just is default. This can go. That can go as well, which is nice. That can go. We do want using allocator type. It's allocator. Like for Visual Studio to catch up, it's very slow when you have multiple things selected. Alright, cool. So this is allocator 3 for all the allocator dots. Okay, cool. So unfortunately, we're not using arenas anywhere. If we go to the game and just make one, what's it called? Arena allocator, I think. See if we can encourage some compile errors. Arena allocator. If I could type. Okay. The associated constraints. There we go. That's what I was looking for. Now that's crazy. Why did that compile? So the global temp arena is using the arena. Of course it is. It's a global temp arena. That's used everywhere. So I don't actually need to put this temporary stuff in. Visual Studio seems to be on a really go slow at the moment. Wow, it's using 4 gig of RAM. I should probably restart Visual Studio. 6.5. Could have been because it was doing a big build. See what it drops down to. Six and a half, 6.77 gig. So what I think we want to actually do now is remove all the default allocator stuff to catch all of these things that are still using the default allocator but we're not actually using in the game, so they're not resulting in compile errors. So let's try and find the first specialization. Where would that be? Probably there. Here it is. So if we knock that out, well, let's just do it. Check in. All right, so if we knock that out, then everything else should come up as a compiler now, which would be good. Awesome. So I think that can go, that can go. And that can go. Global heap. So this actually can actually be, we can take the default allocator out of here as well. It's good because there's quite a lot of duplication that I'm removing, which is always fun. Default allocator, so that can go, that can go, and that can go. All right. Levenstein. Like allocator. So this can go. So what is columns? That seems to work well. So the hybrid lambda stuff. Okay. Let's just quickly, Visual Studio's chugging along at over 4 gigs of mem. So I'm going to just restart this. Okay. Hopefully it's not using 4 gigs of memory now. It's no computer, this. There we go, 300 megs now. Computer is chugging for some reason. Okay, cool. It should be a little bit better now. Okay, so let's start right up at the top. So the lambdas don't use any dynamic memory allocation. The dynamic lambdas do. That's all right though. The hybrid lambdas don't use that. That was easy. Take it out. So this is the hash table, or the map. This is a static allocator now. 0. So these both need to be set to 0. And these both can go. Allocator can go, and then we look for allocator dot. This is allocator static now. Okay. So the binary writer, this is all a static allocator. So we've got push buffer there. even though we're saying what allocator we want it to use. I think it should be push buffer base allocator. That was a little bug there. All right. So this is hash table. You know, the difference between is between map and hash table. They seem like the same. Maybe map is just for strings. Cool. Free list end. What's free list end? It's a maximum number. Okay, so this is default. Get rid of these two. And the allocator dots is just allocator static now. Let me get rid of the allocator. And these go away. Okay, the graphics library is compiling. Looks like this might compile. The engine might compile. Which would be good. Engine compiles. Does the game compile? Nothing to do with default allocator now. In the whole code base. Oh, there is in the nat step filter though. Ah, this is something actually I do want to change as well. I want to add to this. Once I know we're not causing bugs anywhere with this big refactor. Okay, so that was an immediate crash somewhere. dynamic initializers, line readers. So what is this? Okay. So this seems fine. So we're passing 0. Doesn't like passing strings of length 0 into in place. Well, that should be fine. No, it's complaining. Like we do want to set. So if you pass 0 into what is actually the error? Expression elements is greater than 0. So what happens if you just want to copy in the null terminator? That's all I want to do. If there's no n, I do want to copy in a null terminator though. Let's have a look at struct copy. Copies the null terminator by including the null terminator into the character array parameters. Pointer to the null terminator. It's typically the size of the destination buffer. This is the maximum number of characters. Where are we? So maybe it needs to be n+1 everywhere then. That's weird. So that means that here just want to get this right before I change it. Ah, yes, I know what the problem is. It's when we pass in a pointer version, like this one, that must be +1. And also when we do the assignment, that needs to be +1. Yeah, it's the length of the buffer, not the length of the string when you do in place. Ooh, tired. So because we messed about with the allocators, just do a quick check. We'll just watch the allocated memory as well on Task Manager and just see if that's stable. Then we need to rebuild all the assets for the entire game. That'll run all the rec packers and stuff. Make sure all that and all the compression routines, because all that kind of changed a bit. And check that that all works as it did. Okay, so this now should be alright. So this should just be 1 now. Yeah, that's fine. Okay, where did that one go? It's more string stuff. N is 50. So it's trying to allocate a path here. So it wants to create 50 times the size of char type. So this is the buffer size again. So this is +1. because we actually want to, even though this is a view, it doesn't have a null terminator, so we have to put 1 on. The length of ABC would be 3. Because we're making a string out of it, we want ABC null terminator. So we need to put a 1 on to make sure this string allocates for the null terminator. So check it actually puts the null terminator in as well. Okay. So this is it. So it's 51 now. So we need to allocate enough for 51 bytes. Allocate it. Set the top. Okay. So let's have a look at P begin. So this, we did put a null terminator on the end, but did it? Or was that just lucky? So let's have a look at P begin. Have a look at the first 100. So the not is, there's no null there. And let's have a look at strut 100 as well. Okay, that has the null terminator there. What happens if it didn't have the null terminator there? Because it's only a view. It copied it in, but it might, it's only a view. So I think we need to say P end isn't 0. We'll explicitly put it in. But we have to do that after we've copied it. Now maybe we should do this all through. Shallow copy is fine. Deep copy, need to do it. I'll just go up and check all of these. We can do that there. So we're saying n is the buffer size there. Buffer get count. N is the buffer size. The end is that. So it's the buffer size, buffer count, which is the same as the buffer size in this case. That is the end because that's the null terminator, that. So we do actually need, because the buffer might not be null terminated. So we could allocate one past. Yeah. Here's the thing about a move. Doing that though, so that's not part of the buffer. So, ooh. I mean, this is just a bad idea, moving a buffer into a string in general. So assuming the buffer's not null terminated. So if the whole buffer will fit, I think this could be written a bit differently, actually. Because the buffer might not even be full. What do we need to do then? So we're going to go char type p start equals buff.begin. And go while p start is not equal to buff.end. We'll say while p_end is not equal to end. If p_end is equal to 0, break. And then we'll just do p_end plus plus. Bool or auto is null terminated is equals to p_end is equal to 0. And then end is equal to n is equal to p_end minus p start if not is null terminated. N plus plus, right, for the null terminated character. So if it will be, then we can straight up copy. So that's p start, p_end minus p start. if not is null terminated. End is the wrong. Should be P first, actually. P first and last. So if it's not null terminated, buffer plus n well, it doesn't matter, does it? Just say buffer p last, no, p end equals buffer. P end is p begin plus n. Like that. And then if we do p end equals 0 at the end, that'll just stamp the null terminator in. Else, if not is null terminated. Now, if it is null terminated, then we just do p end is equal to that's just p first. If it's null terminated, we can straight up just do that. So what happens if it's not null terminated and it won't fit in the SSO buffer? We need to actually do a malloc here. Olympus72, thanks for the follow. Hope you're alright. Got any questions? Just ask. I'm just working on some string stuff. So it needs to do auto size equals n times size of chart type, right? And then we go auto pointer equals reinterpret cast UA. Well, no, we don't. Allocator malloc size. And then we just basically have to go p begin is equal to reinterpret cast chart type pointer p end equals p begin plus n. P top is equal to the same as that. And then we actually need to mem copy the string in now. So strut and copy into p begin, p first. Oh, the size of p begin is size. P first, p last minus p first, and then we stamp the null terminator anyway. I wonder if we should just explicitly do that there and there. Okay, so I'll just have a look at that. Like, we can't move a buffer into a string, take over its memory if the string's not null terminated. We can if it is. If it isn't, we've got to actually full on create a new string. Like, I wonder if here we should call the destructor on the buffer anyway. Here and here. Nah. So we'll let this build. It'll only take a minute, and then we'll. I don't know if we were getting crash here before, I think. So hopefully we can test it. So obviously now copying a buffer into a string is quite a lot more expensive. So it has to go through and detect if it's a null terminated string or not. Oh, it didn't work. It didn't build. Anyway, let's see. It's not null terminated. So this is none. The data is called none. It says it's not null terminated. I think it is actually null terminated. Oh, hang on. It should be less than or equal to. Does that mean the end of the buffer is not one past the buffer? Ooh, that might be a bit of a problem with buffers. Have to see. Right, I'm just gonna go take 2 minutes to go to the loo. I'll be back soon. There. Let's try this again. So what is buffer end? Buffer base. End. It should be one past the end. Well, let's just see. Should be one past the end, which is what we want. Okay, so the buff now is 546. So we're doing quite a lot of buffers into strings then. What's this? Definitely has a null terminator on the end of there, so that's not working. And that's corrupting the heap now. So it should be going all the way to end. So the end -1 is the null terminator. Doesn't find it. Buff end -1 as a U16. Oh, I know why. Silly mate, it's this, you see. There we go. We're checking actually if the value is 0, not the pointer. All right. Let's try this again. There we go. Detect it now. So it is null terminated. It won't be SSO, but it is null terminated, which means we can just claim the memory off it. So we can't do set it to p last. It needs to be p begin plus n for end. Because it needs to be one past null terminated character. And hopefully we can get out of this header. It takes quite a long time. It takes a minute and a half to build when we change this header because it's right at the top of the header stack. Obviously strings included by loads of different things. Okay, so saying will be SSO there. Ooh. That's kind of wrong. That's the character count. So this needs to do all that check as well. So I think I'm going to change this to not be character. This is last. This is last. So I think all I'm going to do here is just go new this string base standard move buff like that. If I can. Because this needs to do all the check and everything. It needs to basically execute the same code to check that it can fit. It needs to can either fit in the SSO buffer or we can move just to move the memory across. But if we can't do that because it's not null terminated, we need to reallocate. That's operating on the Buffer size. That's gone now. That's operating on the buffer size. That's my length string 1, length string 2. So that's a full length plus the null character. Full length plus the null character. Right, good. Okay then. So it's null terminated, so it can just claim it. So it empties the buffer. That sounds good to me. This one is also null terminated and can claim the memory. This one is also null terminated. There's a load of moving. Because it's like loading config files into buffers by the looks of things. So it's just loading files into buffers, moving them into strings. As long as it's null terminated, it's a very cheap operation. Okay, this one's only 6 characters long. Any 6, it says. Buffer's got 7 in it. 1, 2, 3, 4, 5, 6. Not sure about that. Okay.
Coleridge.
So even if it is null terminated, I think we always want to be one past. So if it is null terminated, p last is the null character. So the buffer doesn't actually have to. Yeah. So actually, do p last plus plus break. So that gets you one past the null terminated character. No, that's right. That's fine. Okay. If it is null terminated,
Oh, Johnny,
P last will be 0.
yeah, all right. I'm just looking at. I'm in my office down
P
Green Lane.
first
I'm just looking at the
minus P
screen
last plus 1.
for the brewery,
Ooh.
and I see that fermenter one's been on chill for quite a long time. And it's got a jet black cask in it. But it's only at 18.7 degrees, and I'm just wondering if the chiller's working correctly. Has anybody had a look at it or commented on that? Oh, yeah, yeah. Okay, thanks. Cheers. Hey, Max, you all right? I just noticed on the screen, I'm in the office down Green Lane. Uh, Fermenter 1 has been on chill for quite a while now, and it's still at 18.7. And it's got jet, yeah, 13 point, it's 1,389 minutes it's on. Yeah, yeah, yeah. It's struggling a bit. Yeah, yeah.
It's not built. It says copy of string
Yeah,
not
well,
built.
might be with
Uh,
flatter as well. Yeah,
okay, so
yeah.
N is
I
7,
don't know what we can do about it, but I just.
which is quests. 1, 2, 3, 4,
Oh,
5,
right.
6. So
Okay.
N is 7 there because it's got 6 characters and a null terminator.
Oh, right.
So let's just have a look at buffer.
Oh, yeah, yeah. Doesn't need as much condition. Yeah. Yeah. Well, we don't mind me poking my nose in, but I just noticed. I just noticed it. All right. Then. Okay. See you later. Bye.
Weird, then it's set number 7. Man, I wonder if I'm getting tired here. I wonder if it's actually N plus 1 there. I need to actually set this to be a random thing as well. Fresh tag. Can we do that? Is that an actual thing that we're allowed to do? Just set it to like CD. Requires a narrowing conversion. See, this is a thing that could be any char type. Let's do um, Whatever, we'll just leave it. Fine. Comes in as all null, I think, in the debug builds. That's not what I want, really. I want it to be fresh memory. Because I'm setting it to null. I want to check that I am setting it to null properly, or at least 1 byte of it, or 2 bytes of it. All right. So when it's 545. So there's 546 characters there. So that's the 545 is the actual length of the string. So last is set to the null terminator. So P top here P top's probably the buffer count actually. Which buffers dot end. So we do want to allocate one past. Do we want to allocate one past? We only want to allocate one past if it's null terminated. Or if it's null terminated, we can just copy it. Otherwise, we have to allocate one past. It's not null terminated, so n is a real character. Yeah, I think that's it. Ugh, brain frying. Why didn't it want to build there? Alright, let's just do a rebuild. Let's buff.end. So it puts end, because I want to put end on the null terminator. That's what's happening. That's why it's a little bit more finicky. Okay. No, it's not building it. A copy of string H was found, but the current source code is different from the version built into. Don't know what that means, other than it's not building, not for some reason not compiling this file. Is null terminated. So buff is 546, n is 545. But it is null terminated. So the last is a null character. So let's just do p first plus n. Is the null terminator. The p top is the buffer end though. There we go. So let's swap the memory over. And again. And again. And again. Okay. So apparently this one will fit in SSO. So the buffer is 7. Which is normal and the null terminator. So we're just going to copy in six characters. 2, 3, 4, 5, 6. And then we're going to set it. End is the null terminator. And then we're going to nullify the end out, which was 6. So it's that one. Which is good. So that works. This is 16. So n is 15. Top apparently is the letter C. Well, it's one past. So it's not even in the buffer, which is good. This is 12. So this one is iron or rock. So I think it's working. Okay, we are getting heap corruption though. Display 1. So it must be here. This never gets called though. So it's when we're doing this format. So what is it actually freeing here? Display 1. Okay, so it's when we're copying in display 1. Dev device name. $32. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It says it's 32. So let's have a look at str 32. Interesting. So I wonder if we want to actually find. So here, 32 won't fit in, but it should be able to fit in this display because the buffer length is, we've got 16 of small string optimization. So it won't. It'll try and malloc this. So we're going to begin. So that is that is a problem there with actually corrupting the heap there by assigning that is one past. So p top and p end equal the same. For row, they equal the same thing. Okay, we have to watch out for that then. Let's try that again. Let's just see if we actually are going to copy in the. So we're not necessarily. So that is the buffer size. So that is actually -1. Let's have a look at all the places we're doing this. That's fine because we're checking that n+1 is there. This one, pn+1, pn+1. I think p end is that there. other dot length plus 1, so that's a null character, so that's fine. Yeah, okay, good. Get this bug free, in theory. So p-end actually, yeah, that's fine. So this is last times size of chart R. So end there is right on it. So my concern actually here is we're not putting the null character on here either. So we have to do result.pend is 0. So last is that includes the null character. I think that's okay. Actually, I don't think we need to do this, because I think it's going to copy the null terminator from the second string. Load up my test project for this that I made at the weekend. Check them all. I do think I want to actually scramble this buffer size a bit. Not the buffer size, scramble the buffer a bit so I don't want it to be 0. Okay. $51. So this one it didn't like. So when it says this as the buffer size, view length is 51. So I think this is just N. N. Yeah. So if we come down into here from a string view, which doesn't have a null terminator in it, yeah, man, Aleph. All right. Thanks for the follow. Got any questions? Just ask, no problem. Just working on just written a new string class. So it's got a few crashes in it. I'm just trying to figure it out. But if you've got any questions, yeah, just ask, no problem. Thanks for the follow. Okay. So n is 51, right? So we're making a buffer of size n. So let's do p begin n of them. N of them. Doesn't like that. 51 of them. And then it's going to re-stamp over it. Which it needs to do because that might not necessarily be set to 0. $54. So does this come from a view? Yeah. Of length 53. So n in this case is 54. So we're looking at what happens down here. So it does set there, the null terminator. It's just that if this comes in from a string view that's part of another string, that won't be null. So we do need to stamp over it here. Okay. Next crash. Okay, so this is coming in SSO copy 16. Other begin, other the buffer end. $16. So the buffer is 16. Still wanted to complain at me for it though. So when it exactly equals the buffer size. $16, right, so this is going to fail for some reason. So the n minus start is 16, which is equal to the buffer size. So the end actually doesn't include the null terminator here. Okay. So B end, what is B end? The end of the string. Which is actually 1. Right. So that doesn't include the null terminator. So that has to be +1. So we're going to do auto n is that. No, I think actually... that is count. Is that right? No, because end is one past. Yeah, no, that is right. That is right. Get through all of these little crashes pretty soon, I think. And then hopefully it can move on. Bar breakpoint here as well. For some reason it's not including it. Anyway. So the count is 7. So we've got basically the word hello, which got 5 words in it. And the null terminator, which is 6 really. Okay, so interestingly there, the end is not the null terminator. Okay, so that's wrong. So it got put in a buffer. The end should be a null terminator, wherever that came from. It's right there. That didn't. So I wonder why that didn't work. N is 6. Ooh, right. That comes from a buffer, you see. So that has to be -1 there. Yeah, we've got it there as well. And we do need also to set p end to 0 in case it comes in from a view. That has to be +1 as well. Because that end is going to be on the null terminator. So we do need ooh. I wonder if we should redo this. Because they're all +1. It's because of this one. This could end up being in place to -1. All right, let's just open up another solution. Which is just a little bit faster to compile at the moment. Problem is I'm compiling the entire game all the time. It's taking ages. It's like a minute and a half every single time I want to build. Okay. I think this N, we need to make this Len. We need to make this called len. And we need to do auto n equals len +1. Yeah, fantastic. Thank you.
Dry office.
Yeah.
It's a dry office.
Yeah. See, this makes more sense doing it like this. And then we're just going to get rid of this. And then when we're actually in place, where are we? Here. This is going to be n-1. No, this is going to be strlen. Stra. Because you might pass a buffer in there that is actually the string in the buffer isn't the full size of the buffer. That was what was happening. Okay, you've got some compilers in here. Kind of. Ah, okay. It's in the test. Let's just unload this. Where's unload project? There we go. Okay. Okay, let's restart that. So this is 3. So the buffer we want is 4. If it fits in the buffer, copy it over. Stamp over. I didn't see it. I didn't get to catch that one. Buffer it once is 1. Thank you. That's great. Thanks, Dan. S2 is ABC, so we're going to move. So we've got end. Okay, so this is a bit of a mistake. Okay. Whoa, we're going to assembly now for some reason. Hang on. Not what I wanted to do. Three. So the count. So we're going to actually rename these. So N. So this is actually len. So I'm going to rename N. Len. And then I'm going to rename count N. So these are the other way around. Oops. Keep pressing F5. Hang on. Let's just go to main and put a breakpoint on there. Okay. So the len is 3, N is 4, buffer size is only 2, so we can't do that. So we're going to call shallow copy. Can't do that. The end is other length. The str copy is actually, so this is where I'm getting mixed up. This is actually the size of the buffer, including the null terminator. So that's actually +1. So I didn't like that. Two, so the buffer is 3. Other size bytes. It is +1. right though. P begin plus 3. Other length is 2, which is incorrect. It's just that. So I don't know what's going on about there. Okay. Do that. To be fair, this is just other.get. Well, it's not size bytes though, because it's in characters. So that was able to do without an allocation. Seems all good. So let's have a look at the first addition operator. Okay, so I'm going to rename this to len1. I'm going to rename this to len2. And this is len3. So we don't need a len 3. I'm going to rename this to n. Same here. So I'm going to rename this so this is len 1. Rename this len. Rename this n. Okay. So p end in this case is plus len. So let's have a look at results.pbegin 10. So we're going to copy in 3. And then we're going to copy in the third character, so there. Four characters. Okay, so that doesn't quite work. If it's a view, we need to do result.pend is 0. So view, if str2 is a view, then it might not be a null character on the end of it. So this is going to be len 1. Oh no, hang on. I'm going to make this len 2. I'm going to make this len 1. And then we're just going to go auto len. It's len 1 plus len 2. So the end is len. And that pn is len. And that's just pend is 0. Let's have a look at pend. All right. So that seems to work fine. So now we're adding a view onto the end, and the view's got F on the end. So it needs to stamp over the F. So P end, oh look. I haven't copied it yet. So if I look at result.p begin, A, B, C, D, E, F. D, 0. So, okay, I'm confused. Is it adding the 0 on or not? It should have put F on. I think it added on that 0, you know. Itself. Because I should have only copied 2 characters, D and E. But it copied D and F. That's pretty... I think I'm going to leave that there because I don't think it should have done that. Strictly speaking, that's a little bit too much for the library to do for me. I know it's nice and safe. Six, 1, 2, 3, 4, 5, 6, and then we've got the null character. So it should copy. We only wanted to copy 2 characters. So it should copy D and E, and that should still remain as -2. So this is when I look at destination. Count is 2. E. So it shouldn't do this. Look, it's putting in the null character there. Maybe that's part of the spec. I don't know. Confuse me. That means strut n copy puts in the null character. Does strut copy do that?
Sat in the office stewing. I just phoned you because I thought.
So this is the buffer length,
It's been on for a long time.
not
and
the.
hasn't gone down much, but I've spoken. I was thinking there's maybe something wrong with it, but Max said he put up
Okay.
a chill earlier than expected because obviously.
So this actually just needs to be BM drill and stra, really.
Yeah, that's all. yeah, really, yeah. It, yeah. What is he doing now then?
N is 14. Let's just put like 20 in there for now. So it is always putting the null character there.
Well, we can take what we can. Yeah, I think we can. Yeah.
Oops. Let's have a look at what it says about strit and copy.
Well,
Copies num characters. If the end of the source C character is found before num character zooming copy, it's padded with zeros until an. If the end of the source strings, so it's padding it with zeros till the end of the source string. That's what's happening.
2. Yeah, so that's what it's doing tomorrow.
So maybe we do want to leave it just in case.
Yeah, anyway, that's what it's doing tomorrow by the looks of it. So, now. That's what's programmed in at the moment. Don't forget the Endeavour Man's coming tomorrow at 6 o'clock. So why don't we load the new software tomorrow? Yeah, after the brew. Yeah, and then come in early on Wednesday. This is nothing. I mean, I don't think there'll be an issue. Wednesday. Well, that works well then.
Okay.
So yeah, because
Quick.
Well, that
So a quick scan over it.
now in the recipe in the new software, and it's different.
So this is len.
Yeah. Well, we'll be able to make sure that the heat ups. Well, we could run a reset batch. Because the reset recipe now. Test everything. And do that, and that will take an hour. Yeah, we'll talk about that tomorrow anyway. So.
Okay. And that's N.
Well, yeah. Oh, yeah. Well, is there any error lights on it now? What you could do is just flip the relay. If it fires up, well, we're all right. The little switch, yeah, on the relay itself. Yeah, just put it in brew, which it will be, and then flip the relay.
The size is actually N. And this is Len.
Well, yeah. Do you know? I know. Well, do you know what? I went to collect Tom's recipe prescription this morning, and she wanted two items, both of which are very important for asthma control. And they only had one item, and I said, "Well, where's the other one?" And I looked at the prescription; it's there. It's on written down. Which we just missed that. We forgot. Sorry. Come back tomorrow. Well, what happens if she dies? You know, in the meantime, you know, they're absolute rubbish. And I've been waiting for this new topical cream. It's kind of chemotherapy for my head, and they haven't got it yet. Although they've just got it now. But I phoned up this morning, and they've got it on the shelf, but they didn't bother to tell me. They said they were going to let me know when it was in. You know, these people, I don't know what it is. It seems.
Okay.
All right, yeah. Well, all right. Well, let's load the new software in tomorrow, and then just decide. I mean, I haven't added that yet, no, but I can put. No, I haven't done that yet. But as I say, it's a recipe item now, so. Um, yeah, it's something we should have actually. Yeah, with a pin number and everything, so you can get in. Yeah, well, that'll be the next phase. What I plan to do is just upgrade the software as it is.
Okay.
All the important fixes, but I didn't want to change anything else. Yeah.
Let's build that,
So,
and let's open up,
yeah, all right.
back up
Uh,
the engine.
yeah,
Have a quick look. Build it in the engine, and we'll see if we've sorted those crashes out.
I did bother you yesterday. I didn't bother anybody yesterday because I thought you'd be all right. Okay. All right. Oh, we should stay in the garden. All right. Yeah. Well, I'll see you tomorrow. Right. Oh.
Oh. I think we're about there now. Hey. Oops. The reason why I'm not using N here is because you could get a buffer that's bigger than the string length. In which case we could just kind of take this out. Might do that. So I've changed a bunch of the underlying support libraries for the engine now, so it probably will need really testing out. Alright, let's see what happens. So it seems to be not wanting to build this string. Okay, so now we're just wanting to put in the empty string. Seems fine. This was one of the things that was crashing before with hello. All right. So this is the buffer being too small. Buffer's 36. Same piece, so we haven't actually reallocated the memory by the looks of it. It's something we could fit in, and then it wouldn't allow us to copy it. What is this? It's the null string.
Yeah, just a parcel for you.
Oh,
There you go.
right.
Bye.
See you later. Confusing. It is annoying that it's not saying it's not built. So where is this coming from? Find parent. Let's have a look then. See you later. Yeah. Okay. So begin plus index, delimit engine. This is a beginning and an end. So it's made a view. And it wants to copy it. So when it wants to copy it after that view, like now. "36 characters long." So how long is this? More than 36. View.length was 36. So it's a incorrect view length there. Oh, hang on. Oh, we only want to copy part of it. That's why. So this needs to be a Stratton copy. Because we only actually want to copy len. That's what it is. Head off in 10 minutes. Hopefully we can get the game running. I haven't had it running all day. In the next 10 minutes. Yes, I'm not entirely sure if we need to do this. I wonder if that will do it for us. Does str copy add the zeros as well? Including stopping at that point. It doesn't actually say that it puts the null terminator in. If we give it a null terminator, it will put it in. If we don't, though, it'll probably go right to the end of the buffer. So maybe I wonder if that actually should be Stratton copy then as well. Just that's probably it. Means it doesn't have to go right to the end of the buffer. So let's just have a look at all of them. Maybe we should Stratton copy all of them. we don't have to do these ends anymore. Okay. Because in theory, this, it said it pads the buffer with remaining zeros. I think it said the remaining buffer with zeros. Now what this one appears to do is just pad 1 0. Padded zeros until the total num characters have been written into it. It doesn't actually say about putting in the null character, you know. Whoa. It means if this copies the num characters from the source to the destination. At the end of the source, C, which is before num characters has been copied, it pads it. That doesn't actually, that isn't the same as saying it puts a null character on the end. Okay, there we go. So we are corrupting the heap somewhere. We're actually whoops. Gonna have to go, man. Work on this tomorrow or tonight. So it's on when we free display monitor. It looks like the renderer is Calling the destructor on the renderer. All right, I'm gonna have to head. I'll figure this out later. It's like we are calling exit somewhere. It's like we're not even getting into the main. It's calling exit. Someone's calling exit. No idea what's going on. All right, I've head. But yeah, I'll be back on tomorrow at about 9:30 in the morning, UK time. See you later.